Hello nerds, it is Kelly Renee Miller here with the Nerdbyte. It is Tech Tuesday today, and today I want to talk about the brain. I delved into my weekly brainwaves that I get via Mensa, and I'll put a link in the description for how you can sign up for those as well, the Mensa weekly brainwaves. And there were a couple things that actually cycle back to one another, completely different reporting journals and reports, but they're related to each other, and I learned about other things as well, and it made me laugh a lot on the inside. So the first is that I don't know if you've paid attention to neuroscience and advancements in that technology, but in 2011, the scientists and researchers translated brainwaves into movie clips. Then in 2014, two scientists actually sent thoughts to each other via a brain-to-brain link. And then that's mentioned in this first article that I'm about to tell you the whole point of in a moment. And then recently as well, computers were able to decode people's dreams into recognizable images, if not clean ones. They look kind of like impressionist paintings. You can Google Google that, like dream images decoded, or something like that. Should lead you to those results. But this, let me just read you the headline. Mind-reading computer instantly decodes people's thoughts. Hello, Skynet. Not quite, though. So that's it. The article is exactly what it sounds like. There's a computer that they tested this theory by taking some people that had severe epilepsy, so they were already going for temporal electrode implants. They were getting that surgery anyway, because that's part of the treatments to determine what is causing their severe epilepsy. They just asked them to perform an additional task, and they had a computer analyze for the amount of time they were looking at images, like look at a face, look at a house, be on the watch for a house that's upside down. 2/3 of that time, the computer was told what they were looking at as it was reading the brainwaves, and then their brainwaves and their changes. And then the other third of the time, the computer just analyzed the changes in the brain, the firing of electrons and things like that. And it was able to predict within 20 milliseconds, which is essentially instantly, unless you're Spider-Man, with 96% accuracy, whether someone was looking at a face or a house. And right now, and there's also a link that this article links to that I'll just give you the direct link to in the PLOS, the PLOS Computational Biology Journal, that has the entire report in all its scientific technical language glory. That was able to do this using actually different methods than other brain mapping techniques, because those were looking at the other previous techniques, or rather techniques looking for different things, such as creating images out of brainwaves, is different than what this was doing. This was recognizing when the brain sees an image. They were looking at event-related potential, like what happens when this event happens, like I'm looking at a face or I'm looking at a house. And also broadband spectral change, so what your whole brain does when you're going from one thought or one image to another. So that's really cool. That's just the first article. I'm going to speed through the second one, just to not keep you so long, because I've had a couple long ones here recently. And the next is in the MIT Technology Review, and it's better brain imaging could show computers a smarter way to learn. So you see how this is cyclical. Computers are now getting better at reading our minds, and we can use that to teach computers ways to learn better. And this is kind of an extension of something or of a technology that on its basal levels is used in voice recognition, image tagging, targeted advertising, things like that. So what machine learning is not Skynet like it sounds like. These machines are not self-aware. They're not searching out information. It's how does they put it? It's instead of having to, I'll just read a direct quote from the beginning of the article. Instead of having to carefully write out instructions for a particular task, you just feed millions of examples into a very powerful computer and essentially let the program write itself. So the way brain imaging is helping that process is the study of how visual information is processed in the brain, which is what the other article is talking about. And the other article, by the way, was via Live Science, and this is via the MIT Technology Review. What this is essentially trying to do? It's using a newish, again, direct quote from the article, newish technique called two-photon calcium imaging microscopy. Dang it, I practiced saying that and I still stumbled over it. To study the way visual information is processed in the brain. So all these studies that are helping scientists map the brain are also helping scientists learn how to build computers that can better learn or map the brain, learn like the brain does and work that way. And all that being said, it's a 5-year project, and what it's trying to do is reduce the amount of information you would have to give a computer to effectively write a program. So basically make it more like a brain. Now I know what you're thinking. This is Skynet, this is the Matrix, this is where the end begins. The computers are taking over, we're about to be driven into a machine-riddled apocalypse. It wasn't zombies after all, it wasn't a virus, it was the machines, like everyone has been predicting since 2001, A Space Odyssey. Shoot, there's even an ad on this page that says cognitive sports are here. See how you can outthink second place. That ad scares me more than anything else I've read in these articles, because one really, really important thing to note about brain study and advancement in brain technology and computers that are trying to work like the human brain, apart from the fact that brains are still infinitely more complicated, and there's actually at the end of this article, there's a really succinct example of this that I've tried to explain to people. Aren't nearly as efficient or powerful as a human brain. For instance, this is Tai-Sing Lee, who's a professor of computer science at CMU, and they're ahead. I want to say she, but it might be a guy. So this person is leading this project, this research campaign. For instance, to learn to recognize an object, a computer might need to be shown thousands of labeled examples and taught in a supervised manner, while a person would require only a handful and might not need supervision. So my point in all of this is that much as computers are advancing and much as our understanding of our own brain is advancing, and we're using that directly with computers, so preoccupied with whether or not they didn't stop to think as they should. Thank you, Ian Malcolm. The computers still need information from us in order for any of this to work. None of the computer learning program doesn't work unless we tell it what to learn, versus a human brain or a self-aware entity, or an actually intelligent versus artificially intelligent sentience, will just learn based on information available to it, as opposed to any computer, including things like Cleverbot that get scary, that just pull information in from a pool. If you never go to Cleverbot and you never contribute anything to Cleverbot or something like that, then it's not getting that piece of information. Versus a person can go anywhere in the world and maybe not encounter anyone in the world, but can encounter a lot of other things. I can go on the internet and search for something like what to talk about for my Tech Tuesday Nerdbyte just because I have decided to look for that information. Those decisions to look for certain kinds of information are things that computers cannot do. So I think we're still in for a zombie apocalypse more than anything else. But one real quick thing, what I also learned about is the BRAIN Initiative. That brain, it's an acronym. BRAIN Initiative, Brain Research through Advancing Innovative Neurotechnologies. President Obama kicked it in April during the in April 2nd, 2003, and essentially it's trying to do what the Human Genome Project did and really expand our knowledge of the human brain. Because shoot, scientists really can't even, science and brain research and things like that still can't even really tell us why we sleep and need sleep, or why we yawn beyond the resting capacity. Can't tell us why we dream, really. There's a lot we don't know. It's 11 minutes now, so keep it geeky, nerds. I'll see you tomorrow with Walt Disney Wednesday. And, yeah. Have good thoughts. And I will see you tomorrow. Bye!